All right, ladies and gentlemen, Advanced Algebra, Chapter 7.5. We're going to learn how to apply properties of logarithms. The first property is the product property. In this first example, we have what's called log base b, and then m times n. Okay, and if you look, the rule here is saying that we can split that up and we can say log base bm plus, okay, notice the plus sign, plus log base bn. All right, let's look at a couple of other examples and let's put numbers in them. All right, so let's start off with log. We're going to say base 3. Now that 3 is a little bit smaller and written a little bit down. Okay, don't write it next to the G like a normal 3. Okay, that's a base. And then we're going to say 4 times 5. Okay, so this rule, okay, or this property is saying that we can rewrite this as log base 3 4 plus log base 3 5. All right, let's look at another one. This time I'm going to take log base, let's say 4, and I'm going to put an 18 right here. Well, 18, think of factors of 18. Okay, there are a bunch of factors of 18. Okay, factors of 18 are 1 and 18, 2 and 9, 3 and 6. Okay, so those are the factors of 18. So I can split this 18 up several different ways. Okay, I'm going to just do it two different ways. I'm going to split it up. I'm going to say log base 4, okay, and I'm going to take the 18 and I'm going to split it into 2 times 9. Well, if I follow my property, I can then rewrite that as log base 4, 2 plus log base 4, 9. Okay, that's one way it could be written. Okay, let me do it another way. So again, let me take log base 418. Instead, I could have said log base 4 3 times 6. So that could be written as log base 4 3 plus log base 4 6. So that's how that property works. Now, you can also go backwards. Okay, I'm just going to do one of them that goes backwards. Let's say I have log base 5 7 plus log base 5 8. Okay, well, going backwards, I can pull these together and I can say log base 5 7 times 8. And then I could go one step further and I could say log base 5, well, 7 times 8 is 56. So that again is the product property for logarithms. All right. If you need to rewatch that part, rewatch it. I'm going to move on to the quotient property. Okay, I'm going to rewrite this. Okay, this is log base b again. It's m divided by n. Okay, and you'll notice in this property that there's a minus sign between them. All right, so when we're dividing and we want to split it up, we use a minus sign. Okay, think of your exponent properties. It follows the exponent properties pretty closely. All right, so let's look at a couple other examples. So let's say we have log base 7, and then we have 4/5. Well, that can be split up into log base 7, 4, minus log base 7, 5. Okay, here's another one. Let's use log base 8 this time. So log base 8, 10. Minus log base 8, 2. Okay, now it's already split up, so I'm going to go backwards and I'm going to put it back together. So log base 8, 10 over 2. Now that can be simplified a little bit further. Log base 8, 10 over 2, that would be 5. So that's the same as saying log base 8, 5. Okay, again, if you didn't quite get that, rewatch the video. Rewatch that part. That is the quotient property. Now let's do another one. Let's do another one. Let's say we have log base 9, and we have, let's say 28 minus log base 9, 7. Okay, that can be written as log base 9, 28 over 7. Okay, let me fix that. There we go. So that would be the same as log base 9, 4. All right, let's move on. The next one is called the power property. You will notice here that we have an exponent on that. So we have log base b m to the nth power. And you'll notice that the n, when we rewrite it, the exponent goes in front. So it's n log base bm. All right, let's look at just a couple of examples. So let's say we have log base 3, 5 to the 4th power. Okay, rewrite it. Well, the 4 goes in the front, so we rewrite it as 4 log base 3, 5. That's it. Okay, the 4 goes in the front. And you can also go backwards. Let's say we have 6 log base 5, 8. Okay, well, the number in front, the 6, that is going to become the exponent. So log base 5, 8 to the 6th power. So that's what the power property says. Okay, rewatch that if you need to. Now, what are we going to do with some of this stuff? Well, we're going to look at, okay, we're going to skip this. We're going to look at expanding a logarithmic expression, and we have to use the properties that we just saw. All right, so let me write one out here. So let's say we have log base 7, and then we have 3x squared all over 5y cubed. So we're going to expand this using the different properties. Now, when we do this, we should do them in a certain order. Okay, when expanding, we first want to do the quotient property. Then we would like to do the product property. Then the power property. All right, so here we go. So I'm going to rewrite this. First, I'm going to start with the quotient property. So I'm going to start with what I just put in red. We're going to do the quotient. So I'm going to rewrite this. Here we go. So log base 7, 3x squared. The quotient property says put a minus sign. Log base 7, 5y cubed. Okay. The next thing we're going to do is the product property. So right here, it's 3 times x squared. That's the product. Over here, it's 5 times y cubed. So I'm going to split that up using the product property. All right, here we go. So now that becomes log base 7, 3 plus log base 7 x squared minus. All right, now here I need to put this in parentheses, and this becomes log base 7 5 plus log base 7 y cubed. Okay, that was the product property. So I did the quotient property, that's in red. The product property, that's in orange. Now, one thing that I don't like is having the parentheses there. So what I'm going to do is I'm going to rewrite that, and I'm going to distribute that minus sign through. All right, so I'm just going to rewrite this before I do the quotient property. Okay, so this minus sign, remember, gets distributed. So when I rewrite this, I'm going to rewrite it as minus log base 7 5 minus log base 7x or y cubed. All right, now I'm going to do the power property. I'll do that in green. Okay, so this 2, this exponent, goes in front. So that's 2 log base 7x minus, okay, log base 7 5. There is no exponent, so that stays the same. Minus, and then this 3 is going to go in front. And that is the expanded form of the problem that we started with. Okay. Again, if you need to, rewatch that very, very carefully. All right, let's look at another one, but let's go in the other direction. Okay, instead of expanding it, let's compress it. Let's put it back together. As soon as I can get this to move. Come on, there we go. All right, let's go backwards. Okay, we're going to compress it back together. So let's say we have, this is our problem. So let's say we have log base 8 4 plus log base 8. Notice the base always has to be the same. Log base 8 x plus log base 8. Oops, let's back that up. Let's say 4 log base 8 y minus 5 log base 8 z. All right, so we're going to go backwards and we're going to put all of this together. Well, first of all, when I put it together, I'm actually going to go in the other direction. I'm first going to do the power property. So when putting it together, we want to go backwards. So we want to take care of the power property. So now this is log base 8 4 plus log base 8x plus, okay, this 4 is now going to become the exponent, so that's going to become log base 8 y to the 4th power minus the 5 is going to become the exponent, so that's now going to be written as log base 8 z to the 5th. Okay, that was step 1. I took care of the power property. Okay, the next step, again, if I'm going backwards, I would do the product property. Okay, well, product property and quotient property from left to right. All right, so here we go. So the plus sign, we're going to get rid of that plus sign, we're going to get rid of this plus sign, and we're going to get rid of this minus sign. Okay, again, rewatch this if you need to. Look at how it's done. So we're going to write the word log base 8 one time. When you're compressing it, you only should have that log, the actual word log, in its base once. Now, since there's a minus sign on there, we know that there's going to be a numerator and a denominator. Okay, let's start with the numerator. That would be the plus signs. Okay, so we've got a 4, and we've got an x, then we've got y to the 4th power. All of this is in the numerator. Okay, that's the numerator. Now the minus sign, that means that's going to go to the denominator. Okay, well that would just be the z to the 5th power. That is our final answer. So going backwards and compressing it, that's what we end up with. Again, rewatch it if you need to see how it's done. All right, moving on. So sometimes with the ACT test coming up and the MCA tests coming up, you may run into problems that look like this. So here is an example of a situation where you would have to apply the properties to find out which answer it is. So let's take a look. Again, we're going to go backwards. We're going to start with the quotient. So that would mean I need to take care of this 2. So let me rewrite that. Log base 4 8 plus log base 4 5 to the 2nd power minus log base 4 10. Okay, now I'm going to do the product Oops, sorry, I said that wrong. We started with the power property, not the quotient. Okay, because we're going backwards. We started with the power property. Now we're going to do the product slash quotient. Okay, my apologies for that. All right, so we're going to need to take care of this plus sign and this minus sign. So again, we're going to write the word log and the base 4 one time. I'm going to draw a line because I know there's a quotient. Okay, well, what's in the numerator? 8 times 5 squared is in the numerator. What's in the denominator? 10. Okay, well, we can simplify the 8 times 5 squared over 10. All right, well, if we need to, we can use our calculator. So 8 times 5 squared is 200. So this is log base 4, 200 divided by 10. And then I can now divide 200 by 10. I get log base 4, 20. So D is our final answer. All right, rewatch that again. Again, my apologies. We do the power. If we're going backwards, we do the power first. All right, moving on. All right, change of base formula. Okay, this is very, very useful. This is where we're going to use our calculator. All right. So what we're going to do is we're going to figure out, using the change of base formula, what does a certain log of something equal. All right. So you'll notice, ladies and gentlemen, that in this situation, the base gets rewritten to the denominator as just log C. Log C. The big number, the A, is the numerator. That's just written log A. All right? Or we can use natural logs. Okay? So you'll notice the base goes on the bottom and the big number goes on top. All right, let's look at a couple of examples. So let's say we have log base 3, 6. Well, I want to know, what does that equal? Well, our calculator cannot solve it as it's written. Okay, we cannot use our calculator to solve that yet. We have to rewrite the problem. So we rewrite it as log with a 6 divided by log, and then that base of 3 becomes a big 3. I know that looks a little weird, but that's what happens. So now I can use the calculator. So log is on the left side next to the 7. So you hit log 6, you got to close it, divided by log 3, close it. And so the answer to log base 3, 6 is we're going to say approximately 1.63. So I'm going to do approximately 1.63. The cool thing is you can use natural log instead. So let me take the same problem, log base 3, 6, and let me rewrite that with natural log of 6 over natural log of 3. So on the calculator, the natural log is next to the 4. It's under the log button. So you can do log of 6 divided by natural log, whoops, wrong button, natural log of 6, close it, divided by natural log of 3, close it. You get the exact same answer. So it does not matter which one you use. Okay, let's just do that one more time. So let's say we have log base 324. That's the same. So the change of base formula says log of 24 divided by log of 3. So log of 24 divided by log of 3. So it's about 2.89. And again, you could use natural log. You could say natural log of 24 divided by natural log of 3. You're going to get the same answer. Memorize that change of base formula because you're going to have to use it a lot. All right, let's see what's next. I do have there, sometimes you actually might have a base that is a fraction, like 1/5. So log base 1/5, 9. Just be careful with that. Okay, you still take log of 9 and you're going to divide it by log of 1/5. Just make sure you're using parentheses when you do that. All right, let's see what's next. All right, so you do have a problem on your worksheet that is going to use this property of logarithms in real life. It has to deal with sound intensity. Okay, so let's take a look here. For a sound with intensity I in watts per square meter, the loudness, Li, of the sound in decibels is given by this formula, where I sub O is the intensity of a barely audible sound, which is about 10 to the negative 12 watts per square meter. An artist in a recording studio turns up the volume of a track so that the sound intensity doubles. By how many decimals does the soundness increase? Okay, well, the I sub O equals 10 to the negative 12. That's what it says right here. All right. Now, it says that we want the sound's intensity to double. So to double that, that would be 2 times I. Now, if I'm going to plug numbers into this formula, okay, I'm going to write this out. So I've got 10 log, okay, then I'm doubling the intensity, right? So I say 2I over the I sub 0. All right, I just double checked the worksheet, and we're not going to look at something like this. So I'm going to do one of the problems from the worksheet. So let me rewrite this. We're going to need to use this formula. Now, we know that this is 10 to the negative 12. Now, looking at number 62 on your worksheet, let's look at A, the dog barking. So find the decimal levels of the sound made by each object shown below. Now, you'll notice that A says that the I equals 10 to the negative 4. All right, well, This is going to get plugged in here. This is going to get plugged in there. So we're going to rewrite this. 10 log 10 to the negative 4 over 10 to the negative 12. This is way easier than the example I was just looking at. Now, I need to use my exponent rules here, or my quotient rule. Okay? So now this becomes 10 log. Now think about your exponent rules. That's going to become 10 to the 8th power. Okay, 10 to the 8th power. Okay, because we added our exponents here. Okay, or I should say subtracted, and we got 8. Use your exponent rules right here. Cross the line, change the sign, so negative 4 plus 12 would be 8. Now, using my exponent rules, okay, my power property, that 8 is now going to go in front. So 8 times 10 log 10. Well, 8 times 10 is 80 log 10. Well, that can be typed into the calculator. 80 log 10. And that's just going to be 80. And that's our answer. So, the decimal level of a barking dog is 80 decibels. All right, see if you can do the sound of the ambulance siren. Just follow my steps. And then the B. What's the decimal sound of a B? All right, good luck.